Hello, 7th grade pre-algebra. This is our last new section for this week before you have a week of spring break. We're on 9.6 and the topic is special right triangles. Sometimes it helps to know, like, how important is this topic? This topic is so important, but not really until you get on in trigonometry. I've been tutoring several kids who go to Brighton, 9th grade. They're taking geometry, and we were just covering this topic. So just so you know, this you will see again. Now, I love trigonometry, and I kind of have my own way of solving these triangles. It seems to be hopefully easy to understand. You can go ahead and take a look at the book. If you read the book and you're like, oh, this is great, then just do the book's method. My way is just a little bit different. So anyways, let's go ahead and begin. The two triangles that you have to know are a 30, 60, 90 degree triangle and also a 45, 45, 90 degree triangle. That's it. They're just two, but you must memorize these two triangles. All right, there's a theorem in geometry that says in a 30, 60 right triangle, the side opposite the 30. Now we're going to start talking about trigonometry in a minute here, and we need to know, what does that mean, opposite? So you know that the hypotenuse is opposite the right angle. That's the side opposite. So here's an angle. Do you see the two sides that make up that angle? So the opposite side would be the side that's not part of the angle itself. So here's the 30. You know, an angle is made up of two rays. These are the rays. So this would be the opposite side to the 30. And this would be the opposite side of the 60. All right, some kids really struggle with getting that opposite. So here's our theorem. The side opposite the 30 degrees is half the hypotenuse. So if we just choose what I call ratio numbers, if this side were 1, this side would be 2. The side opposite the 30 degree angle is half the hypotenuse. And if we did the Pythagorean theorem, a squared plus b squared equals c squared, and solved, we would get b squared is equal to 3, 4 minus 1, or this side is equal to the square root of 3. So we have to say the side opposite the 30 is half the hypotenuse. Repeat that right now wherever you are. The side opposite the 30 is half the hypotenuse. 1, 2, and then we say 1, 2, and the square root of 3. Repeat that. 1, 2, and the square root of 3. So if you can get these numbers on your triangle on the right sides, then you're doing great. Another thing to help you remember is that the hypotenuse is always the longest side in a triangle, and 2 is bigger than the square root of 3. 2 is equal to the square root of 4, right? So 2 is bigger than the square root of 3. Why am I circling those numbers? Because these are the ratios of the sides, the ratios, how they relate to each other. Okay, we are going to do this one next. Let's do this. Okay. When we have a 45-45 right triangle, there's a theorem in geometry that calls this triangle isosceles. If these two angles are the same, then these two side lengths are the same. So if they're the same, we're just going to call them both 1. 1, 1. And again, if you did the Pythagorean theorem, a squared plus b squared equals c squared, 1 squared plus 1 squared, 1 plus 1 is 2. This would equal the square root of 2. Now say this after me. 1, 1, and the square root of 2. 1, 1, and the square root of 2. Over here, 1, 2, and the square root of 3. 1, 2, and the square root of 3. Okay, now we are ready to solve triangles. Our proportion, remember proportions are two equal ratios. We've done these before. We're just going to put the real distance over the ratio number. What's the ratio number? These numbers in pink. Those are ratio numbers. Okay, how does that look? Here's example 1 in your book. And it says we have a square mat, square, so each length of side is 12 meters. How long is the diagonal? Well, if we have a square, we recognize which triangle are we working with? We're working with this guy, right? Okay, so we always start with a picture. I'm going to put my ratio numbers in. 1, 1, and the square root of 2. 1, 1, and the square root of 2. So let's do a proportion. Let me do the proportion in green. The real distance is 12. 12's ratio number is 1. This is our unknown. Let's call it x. We want to know how long is this diagonal. The real distance we don't know, but we do know the ratio number is the square root of 2. If you want to pause and take a look at that, do so. Real distance over ratio number. Real distance over ratio number. All right, now we just need to solve for x. Well, x is divided by the square root of 2. A simple solving the equation, we know that we need to multiply both sides by the square root of 2. So we get x is equal to 12 times the square root of 2, and that's over 1, right? And we're done. Now there are easier ways. I don't know if there are easier ways. What I want to say is the more you do these type of problems, you can say, oh, well, if I know that's the 1, my scale factor, my multiplier is 12. 1 times 12 is 12, so just 12 times the square root of 2. You'll get to that point. If that doesn't make sense yet, don't worry about it. All right, let's move on. Let's do the next example 2. We have a triangle here. If this is 30 and this is 90, we know that these two angles must add up to 90. So we got the 60 here, right? It's going to be a 60, 30, 90, 30, 60, 90. All right, so we're going to use these numbers right here. The side opposite the 30 is half the hypotenuse, 1, 2, and the square root of 3. Let's go down here. The side opposite the 30, bam, is half the hypotenuse, bam. 1, 2, and the square root of 3. Now we can solve for either x or y. I'm going to use blue because I don't know if you can see that green very well. All right, remember it's a real number over ratio number. So let's start with a pair that we do know. 8 is to 1 as x is to 2. Ratio numbers go on the bottom. How do we solve this? Multiply both sides by 2. X is going to equal, do you see how those cancel? X equals 16. Let's do it again to find y. 8 is to 1 as y is to the square root of 3. How do we solve this? Multiply both sides by the square root of 3. And we get y is equal to 8 square roots of 3. Pretty nifty. All right, we got one more example. This problem, example 3, in your book is simplified to this. We've got a 30 degrees, so we're going to use these ratio numbers up here. Always write your ratio numbers in on your diagram. So this is why I had you say this several times. The side opposite the 30 is the 1, It's half the hypotenuse, so this is 2. 1, 2, and I hope you all said the square root of 3. We have our ratio numbers in place. Now, let's solve for x, shall we? So start with the two numbers that you know, real number over ratio number. 294 feet is to 2 as x is to 1. Well, this is pretty nice. X over 1 is just x. We just have to divide this. X is going to equal 294. I don't trust my brain. 294 divided by 2 is 147. And that would be feet. And then now let's find y. So we have 294 is to 2 as y is to the square root of 3. How do we solve this? Multiply by the square root of 3, and we would get y is equal to, we already know this is 147, so this would be 147 square roots of 3. If we've gotten to this point and you're not sure how I got my answers, I would recommend that you replay the video because a lot of times seeing something through for the second time will really cement it home. All right, good luck. Thank you.